we saw that conditional introduction is a rule of inference that makes use of a subproof. So let's talk about subproofs in a little more detail. Conditional introduction is just one of several inference rules that rely on subproofs. In particular, the following rules all make use of subproofs: conditional introduction, biconditional introduction, disjunction elimination, negation introduction, and indirect proof. So far, we have only encountered the first of these, but more are to come. In each of these cases, the basic idea behind subproofs is that they symbolize the introduction of additional assumptions into your proof. So whenever you open a subproof, meaning whenever you draw an additional vertical line, you introduce additional assumptions into your proof. And everything that you derive within the subproof depends on these additional assumptions. And then when you close the subproof, meaning the additional vertical line ends, you discharge these additional assumptions. So that means that sentences which you infer after the subproof has been closed do not depend on assumptions made within the subproof. And so to correctly make use of subproofs, you need to obey a couple important constraints. The first is that after you've closed a subproof, you can cite the entire subproof to justify steps that come after the subproof. So all the rules of inference that I just told you about, conditional introduction, biconditional introduction, disjunction elimination, negation introduction, and indirect proof, they all require you to cite entire subproofs. But you cannot cite individual lines from within a subproof after that subproof has been closed. So here are two examples, one example of what is okay and one example of what is not okay. As we have seen, if under the assumption that A, you can infer B, then you are licensed to infer the conditional if A then B and justify this inference by citing conditional introduction as applied to the entire subproof M to N. This is okay. This is a correct use of a subproof. Now, here's an example of what's not okay. Suppose that under the assumption that A, you can infer B, and then you reiterate B in the next step of your proof. And you justify this step by citing the rule reiteration as applied to line N. This is not okay. And the reason is that in line N, the inference to B depends on the assumption that A. But you do not want your overall conclusion at the end of your proof to depend on the assumption that A. You discharge the assumption that A when you close your subproof. Now, if you were to simply reiterate the sentence B in the next line of your proof, this reiteration would still depend on the assumption that A, and that you do not want. So in order to avoid this kind of mistake, simply pay attention to always only cite entire subproofs and not individual lines from within a subproof. So you may observe that in the correct application, or when we look at the correct use of a subproof, we are citing the entire subproof from line M to line N. When you look at the incorrect use of a subproof, here we are citing only one line from within the subproof, namely line N. And that is not okay. So let's cross this out. Never do this. The very same constraints also apply if you open subproofs within subproofs. So sometimes you will be required to start a subproof after you have already started another subproof. So you have kind of nested subproofs. In these cases, you can cite individual lines from the outer subproof within the inner subproof, but you cannot cite individual lines from the inner subproof once it has been closed. Here's again an example of what's okay and what's not okay. On the left-hand side, we see a proof that makes use of two nested subproofs. In line M, we introduce the assumption that B. In line N, we introduce an additional assumption that A. And to mark this introduction of an additional assumption, we open a second subproof. And then in line O, we are able to derive B using some inference rules, in this case, reiteration applied to line M. And then in line O plus 1, we can infer that if A then B, citing conditional introduction as applied to lines N to O. And then in the next step, we can infer that if A then B, again citing conditional introduction as applied to lines M to O plus 1. So this is entirely okay. You will notice that whenever we cite conditional introduction, we apply conditional introduction to entire subproofs. In the first case, to the subproof that starts in line N and ends in line O. And in the second case, we apply the rule to the subproof that starts in line M and ends in line O plus 1. So this is fine. Here's an example of what's not okay. Suppose that in line M of your proof, you introduce the assumption that A, and in the next line of your proof, you introduce an additional assumption that B, marked by the opening of an additional subproof, and then you are somehow able to infer C. If you were now to reiterate C in the next line of your proof, O plus 1, and justify the step by citing reiteration, that would be an incorrect inference. The reason is because in line O plus 1, the previous subproof that contains line O has been closed. So you cannot cite a line from within a subproof once that subproof has been closed. And so if you were then to go on and conclude that if A then C, citing conditional introduction, that would not be a valid inference because the previous step in line O plus 1 is invalid, is not a correct application of the rule reiteration. And as before, you will notice that the crucial difference here is that in the cases that are okay, we cited entire subproofs, and in the cases that are not okay, we cited individual lines from within a subproof after that subproof has already been closed.